Well, boys, back again. We're moving on to chapter 14, just one section we're going to talk about. And this is going to be about trigonometric functions. And we're going to talk about quadrantal angles. This is just going to be a quick introduction to this for you. This is not, I'm not going to test you or quiz you in depth on this. But I am going to ask you to just take a good hard look at it. So, trig functions, especially on the xy coordinate plane, are defined as when we take xy as any other point anywhere else in the xy coordinate plane other than on the origin, and on the terminal side of an angle, what they call theta, that's that symbol, in standard position. So, the distance from the point to the origin is calculated as the square root of x squared plus y squared. You'll notice that we have a little right triangle there, and that basically is what we call the distance formula. You'll learn that in geometry. So what we're doing here is any point can create a right triangle, and what we'll be able to do is to use the Pythagorean theorem. If you remember, the Pythagorean theorem was a squared plus b squared equals c squared. Well, we use x, y, and r when we're on the coordinate plane. So the distance from the origin of point Q that you can see here on the plane in the drawing is the distance of x, right? The absolute value of the coordinate of Q, right? The x value of Q. The y value is the absolute value of y, that distance, right? So if we want to find r, so it was x squared plus y squared equals r squared for the Pythagorean theorem. So we just take the square root of each side, and it would be r is equal to the square root of x squared plus y squared. So we're going to use that data and that information to work with these trig functions. So there's 6 trig functions of theta. These are defined as follows. The sine of theta, which would be y over r, cosine x over r, and tangent y over x. Now, some of you may remember, and you may not have seen this, you may have, but I'm just going to talk about this. I always taught my geometry students the secret code word of trig was SOHCAHTOA. So the sine, in this case, would be of the theta, would be the opposite over the hypotenuse. The cosine of theta would be the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So O stands for opposite. A stands for adjacent, and H, that's ugly. H stands for hypotenuse. So in that right triangle we saw earlier, if you remember what it looked like, that angle is the angle between the hypotenuse and the x-axis. Okay, so that's what theta would be. Now, we also have what's called the cotangent, and the cotangent, and in all these, nothing can be equal to 0. The cotangent is the reciprocal of the tangent. So all of these here are going to be reciprocal. So let's go through these. The cotangent, the secant, and the cosecant. Okay, so this is the cotangent, the secant, and the cosecant, and those are all reciprocals of those initial 3 trigonometric functions. We're going to see that we have here is, again, let's label this. For this angle, this is 15 is opposite, and for this angle, since it's right next to it, 8 is adjacent. So sine opposite was 15, and hypotenuse is 17. The cosecant is reciprocal, so it would be the hypotenuse over the opposite. The cosine is the adjacent over the hypotenuse. The secant is just the reciprocal of that, or the hypotenuse over the adjacent. The tangent was the opposite over the adjacent, so the cotangent would be the adjacent over the opposite. All right, let's take a look at a different one with negative values. So, terminal side of theta in standard position passes through the point -3, 4. Find the values of the 6 trig functions of angle theta. So, here we go. This angle, first thing we're going to do, this is a 3, 4, 5 right triangle, right? -3 squared plus -4 squared is equal to 25, which is the square root of 25 is 5. So we're going to use the definitions now to find that. So these would be -4/5 would be the sine of theta. -3/5 would be the cosine of theta. The tangent of theta would be -4/3 or 4/3. Cosecant would be -5/4. The secant would be -5/3. And the cotangent would be -3/4. All right, now we're going to find the 6 trig function values of angle theta, which is that big angle there. It's at a position if the terminal side of theta is defined by x plus 2y equals 0, x is greater than or equal to 0. So we can use any value to find the xy coordinate there. So we're going to use 2, -1. So we're going to plug in 2 and solve and get -1. So y would equal -1. Okay, once we plug in. And since 2, -1 lies on the terminal side, and the corresponding value of r is equal to 2 squared plus -1 squared, so square root of 5. So that's the length. So we end up with sine of y over r, so that would be -square root of 5 over 5. And you've got to rationalize the denominators. Don't forget to do that. The cosine would be 2 square root of 5 over 5. The tangent would be -1/2. The secant would be square root of 5 halves. The cotangent would be -2, and the cosecant would be -5. Now, you'll notice they are all reciprocals, right? We've got a lot of reciprocals there. All right, so we've got a 90-degree angle here. So we're going to solve. Terminal side passes through 0, 1, so x is 0, y is 1, and r is 1. So we put those in. And what we defined here is that some of these are undefined. So secant is 1 over 0, that's undefined. The tangent of 90 degrees is 1 over 0, that's undefined. Alright, so find now the values of the 6 trig functions for an angle theta in standard position with terminal side through -3, 0. So x is -3, y is 0, r is 3. So we can just go through these, and we will see that the cosecant is now undefined and the cotangent is undefined. Alright, so if the terminal side of a quadrantal angle lies along the y-axis, then the tangent and secant functions are undefined. The terminal side of a quadrantal angle lies along the x-axis, and the cotangent and cosecant functions are undefined. So here's a little chart that we can use. And you're going to be looking at quite a bit of this next year in pre-calculus. So basically, once you have your sine figured out, so sine of 0 is 0, 0-degree angle, right? So sine of theta is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0. So you're working your way around the origin. Cosine is 1, 0, -1, 0, and 1. Tangent, 0, undefined, 0, undefined, 0. Notice those all come out. The zeros are undefined. So now the reciprocals. Well, the reciprocal of 0 is 1 over 0, which is undefined for cotangent. Undefined would be, 1 over 0, so 0 over 1 is 0. Undefined again, 0, undefined. So notice within this realm here on cotangent and tangent, they just flip. Okay, the secant goes with cosine. Let's see, work together. Reciprocal of 1 is 1. Reciprocal of 0, undefined. Reciprocal of -1, -1. Reciprocal of 0, undefined. Reciprocal of 1 is 1. Over here, the cosecant, which is sine. So, the reciprocal of 0 is undefined. Reciprocal of 1, 1. Reciprocal of 0 is undefined. Reciprocal of -1 is -1, and the reciprocal of 0 is, again, undefined. Alright, so using a calculator in degree mode returns the correct values for sine of 90 and cosine of 90, but the second screen shows an error message for tangent of 90 degrees because 90 degrees is not in the domain of the tangent function. Okay, so make sure you don't make errors. Make sure your calculators are not in radians. They need to be in degrees. So that's one of the most common mistakes that cause bad answers on tests. So make sure that you are in degree mode. Alright, so this was just a little introduction to trig functions.